What is a rock? You might think this is an easy question to answer, but rock is both a common word and a scientific term. And sometimes this causes confusion over whether or not something should be called a rock. In geology, a rock is solid, naturally occurring, and made of minerals or mineraloid matter. So this means to understand what a rock is, first we have to explore minerals. I'm Science Mom.
I'm Math Dad.
Today we're going to show you some simple tools that you can use to identify rocks. Welcome! Today we're going to be learning how to identify rocks. But first, like we said, we're going to dive into minerals and give a quick welcome to some of our viewers watching live. Hello to Kendall from Illinois, Elise from the UK, and Mariah watching in California, Shyla from Texas, Cassidy from Mississippi, Xander and Amelia from Alabama. We're happy to have you with us, and a special welcome to you if you're watching the replay.
I'm pretty excited for this because I'm not very good at recognizing rocks. I think I can usually tell what is a rock, although that can actually be a little more complicated as well.
There are a couple important tools that will help you identifying rocks. One is to recognize how hard the rock is. We'll talk about mineral hardness in a minute. The other is to be able to look closely, and a magnifying glass can help, and see, are there visible crystals? Are there layers? Those three things are clues that can really help you identify a rock. And then the fourth one, which is also very important, is where did the rock come from? Because location can be really helpful. But before we dive into those processes, let's talk about quartz, one of my favorite minerals of all.
So quartz is a pretty common one, right?
It is. And I have a sample of quartz right here, 2 of them. And you can see that it has a really pretty crystal structure. Parts of it are even a little bit translucent, and it was not carved like this. This quartz crystal grew into this shape all on its own.
What?
Because it is a crystal.
Whoa, it looks like glass. It's so clear almost. No way, so that's naturally occurring.
This is naturally occurring. This is natural quartz, and it grew like this. Now, a crystal is something that has a regular repeating pattern. And there's a really common crystal probably in your fridge right now. It's called ice.
Oh.
Because when water...
in our freezer for sure.
In your freezer, that's what I meant. Because water, when it freezes, it likes to lock into a pattern, into a crystal pattern. And quartz, which is made out of silicon and oxygen, quartz does the same thing.
So now, like in a cave? Or how does that, or underground? Underground. So yeah, it forms underground as igneous rocks are cooling down really slowly. You will get quartz forming. Now, this is quartz, but this is also quartz. This is smoky quartz. If you can zoom us out just a tiny bit, Math Dad, so they can see that just a little bit better. Whoa.
Look how cool these crystals are. They're all growing up, and again, this is naturally forming, but the color is completely different. So color of a rock turns out to not be the most useful thing in determining what a rock is, because this is quartz, and this is quartz too. Now, It's a little hard to see with our light here, but this is actually yellow. And if this is polished and cut to be a gemstone, then it looks like this. This is citrine, raw citrine, and then polished and cut citrine. It is also quartz. It's a yellow variety of quartz.
No way. I mean, this one looks like a gemstone.
It is a gemstone.
In a ring.
Yes.
Yeah. Those are all quartz.
These are all quartz.
That makes almost no sense. So what is causing the difference in the colors?
Tiny amounts of other elements or other atoms. So quartz is mostly made of silicon and oxygen, silicon oxide. But there are other little elements that can get in there, and just a little bit of a certain element can cause a huge difference in color. And we see this especially with corundum. Have you ever heard of corundum, Math Dad?
I have. That's a pretty hard one, right?
It is a pretty hard. It is a gemstone, a mineral, and depending on which variety you have, it will be different colors. And it could be, do you remember the 2?
It's ruby.
It could be a ruby if it's red.
Or sapphire.
Or a sapphire if it's blue. And then there are colors that are sort of in between that spectrum as well, but they're the same thing. They're both corundum.
So just other impurities or other elements are somehow in there, and that's where we get the difference in color?
That is where we get the difference in color. Let's talk just a little bit about gemstones, because when some people hear mineral, they think, oh, like diamond and quartz. So we're just talking about things that we would put in someone's crown, right? We're just talking about jewelry. Well, no, we're not just talking about jewelry, but gemstones are very valuable to us human beings because they are so hard and beautiful, and you can cut them into these expensive and gorgeous shapes. And so we like gemstones as a species, but there are a lot of variety with our gemstones. Let's take a look at some cool examples. So this is not necessarily a gemstone, it's a rock. It's called tiger's eye, and it's usually polished to look like this. And I brought this just as an example to see how different something can look when it's raw versus polished, because here is tiger's eye before being polished.
Okay, so what does one do to polish a rock?
You've got to tumble it. So people will have rock tumblers, which basically is just a big barrel with some rough stuff in it like sand, and you just tumble it around and around and around, kind of like what would happen naturally in a river.
Okay, so that kind of breaks off any corners and it smooths the edges.
It out.
But how does it make it shiny? Does the tumbler make it shiny?
Yeah, just getting it smooth. So this surface here, if we polish it and get it really smooth, it would also look similar, but this has been cut but not polished as smooth as this one has. So these are all tiger's eye. This is raw tiger's eye that hasn't been tumbled or polished yet. This one has been cut but not polished. And then here is one more example. This is aquamarine, another gemstone. This is raw.
So it's a slightly bluish cast to it. Is that where the name aquamarine comes from?
And this one is polished. And if it was cut to look like a gemstone, then it would look sort of like a bluish diamond, only this is not as hard as a diamond.
Well, that's way cool. I mean, I couldn't recognize a diamond. Even if I had a magnifying glass, I wouldn't know what to look for, although professionals do know what to look for.
Professionals do. And then this right here, this is opal, common opal. You can see it has a beautiful color. And if we were to polish it and cut it a little bit more nicely, this is used as a gemstone as well. But this is not a mineral.
Wait, what's a mineral then?
Because remember, a mineral is something that has a regular crystal structure where the atoms are stacked and arranged in a really organized way. And if the atoms are not arranged in an organized way, if they're just kind of, all over the place, then it is not a mineral. And we can call it a mineraloid, like it's similar to a mineral. And obsidian is a great example. Obsidian is volcanic glass. It's an igneous rock that cooled down really quickly. The atoms here, because it cooled down so quickly, they did not have time to organize themselves and get all into a crystal structure. And so this is what we call amorphous. That means the atoms are not lined up. So this is obsidian. If we were to cut it and maybe make it look like some sort of a black gemstone, it would not be a mineral.
It's a bit mineraloid.
Mineraloid. Yeah. And there are several things that are not minerals that we call precious gems. Let's take a look at our notes real quick. We're going to be on page 81. And I have a little Venn diagram to help kind of separate it out. What's a mineral, what's a mineraloid, and what is a precious gem or a gemstone? Because they're not all the same thing. So we'll come back to this one in just a minute. Here we are on page 81.
All right.
Now an opal, the stones that we were just looking at, these are gemstones. They're often used in jewelry, but they are not minerals. They don't have a crystal structure. Pearls come from oysters. They're actually made by a living thing, and they are beautiful, but they're not a rock. They're not even a mineral because they are made by a living organism.
Oh, and that's part of that definition.
Yes, same thing with amber. So amber is fossilized tree sap. It looks really beautiful and sometimes can be used as a gemstone, but it is not a mineral and not a mineraloid either. It's kind of a separate thing.
Interesting.
And then coal can actually be cut and into a gemstone if it's hard enough, and that's called jet. So here is a piece of coal. This is actually a hard enough piece of coal that if we wanted to polish this, we could, and it would be a gemstone called jet.
Jet. Okay, that's a cool name for a gemstone.
It is.
I think we can all agree on that. Oh no, sorry, we hold up the coal again.
Hold up the coal
We
again.
were in the small picture mode.
There we go. That is a piece of coal.
Crazy.
So is coal a mineral, Math Dad? Don't look at the flow chart.
Oh man.
No hints from the chat.
So it's yeah.
Is it a mineral?
Does it have a crystalline structure? So yes, it's a mineral.
It is not a mineral.
What? Why not?
It does not have a crystal structure.
Okay, it doesn't have the crystal structure.
It doesn't have a crystal structure. Are you going to find coal with little crystals of coal growing out? No, because it is not a mineral. All of the atoms are kind of smushed in and they are not organized.
Gotcha.
But there are lots of different types of minerals. And one of my favorites is called selenite. Take a look at this. This is sometimes called desert rose. Shout out to Ibrahim from Canada who identified that correctly from the thumbnail. And it is naturally forming. It forms like this all on its own. And these little ribs that come out that are dusted white, that happens because it is a mineral and those atoms want to line up in an organized way. They want to be all lined up. And this forms naturally just like those quartz crystals did.
That's neat. I saw that the chat, everybody was getting the question right that I got wrong. So coal is not a mineral. I'm gonna remember that one from now on.
Good job, unbeatable science kids. I want to show another example that color is not a very good thing to use when you're identifying rocks. And that's because this and this are both feldspar.
What?
Feldspar is one of the most common minerals on our planet. A lot of rocks have feldspar in them. And it's not a mineral that you're going to see growing into crystals like you do quartz, where they're a really pretty glassy structure. But if you look under a microscope and you look at the structure, there is an organized lattice to this mineral. And certain types of feldspar will actually form layers. This is labradorite feldspar. Isn't that beautiful?
Yeah, it is.
But you don't see it unless you polish it. Without being polished, it looks like this. You can kind of see that there's some striping there, but it's not nearly as obvious.
And this makes me want to polish some rocks.
Yeah, got to get a rock tumbler. But both of these are feldspar. Do they look the same?
Not at all. I would never guess that those were the same mineral.
Very, very different appearances. And they're a lot of different varieties of feldspar. But if you look at what the atoms are and what they're made of and how the crystal forms, they're pretty similar, even though they have totally different colors.
Okay.
Next,
way cool.
There's one more mineral I want to talk about that you actually have in your kitchen right now.
You're talking about our granite countertop?
Nope. Nope, not the granite countertop, although the granite countertop might have some quartz crystals in it.
But granite itself isn't a mineral.
I'm talking about a mineral that you eat. And if you're watching the replay, see if you can guess the answer before Math Dad.
A mineral?
A mineral that you eat that is in your kitchen that can form a rock.
Okay, I've got a theory. It's got to be the milk, the calcium, the calcite.
Nope. Amy's got it. Dexter's got it. Rachel's got it. I love
what?
It is
it's salt.
Oh. This is halite or rock salt. And we call it rock salt because it literally does form rocks. So this forms on the top of a lake bed. And when they went and harvested it, it looked like this. And you would reach underneath and then break it up. And when you turn it over, you see these incredible crystals.
Those are huge.
They are huge. And they have a square shape because salt forms a cubic crystal.
They meet at right angles. Yeah, it really isn't like a pointy diamond.
No. So Math Dad, is this a rock?
Well, are minerals rocks? Because yes, it's got to be a rock. It's natural. It's got a crystal formation, and yeah, it's a rock. Yes.
It all depends on how you define rock, and sometimes people will get in arguments. Even fellow geologists can get in big arguments about whether or not something is a rock. But if we define a rock as being naturally occurring, that means it's not man-made or animal-made, and that it is made of minerals or mineraloid matter, and that it is solid, then this is a rock, and it's made of salt. But this rock here, if you dropped it in a bunch of water, it would eventually dissolve because it's made of salt. It is rock salt.
It's kind of weird to think of a rock dissolving.
And if this rock is put under a lot of pressure, there are certain rock salt deposits that would not dissolve very easily because they are so compacted. But this one was formed on the top of a lake and it would dissolve.
It's beautiful.
So that's why we're not getting it wet.
So something like a brick is not a rock because it was man-made.
That's right. If an
Wow.
animal helped to create it, then we don't call it a rock because rocks are naturally occurring out in the natural world without some animal making them.
Way cool.
Now we are ready, I think, Math Dad, to try identifying a rock.
Okay, I'm
I
ready.
have a rock right here, and we are going to go through our little flow chart and see if we can figure out what this rock is.
Oh, so this is the flow chart in the notes on page 80 to which you refer?
That is right. And this first question on our flow chart has to do with where you are. And when you're identifying rocks and trying to figure out what a rock is, the best question to ask first is, where did the rock come from? Because there are geologic maps that will show you what type of rocks occur where, and that can be really helpful as you try and figure it out.
Okay,
So first question.
Is the rock soft enough to flatten with 2 fingers?
This is a fairly important one because sometimes you'll pick up what you think looks like a cool rock, but it actually might be something like deer poop. And if it's squishy, then go wash your hands because that was not a rock.
All right, so the answer is no in this case. So looking at this particular rock. All right, so ooh, look at that.
Ooh.
2 for 1.
Are we in Hawaii? Did this rock come from Hawaii? No.
Okay.
If it did come from Hawaii, then most likely it was basalt.
Yeah. Okay. So no, we head down here. If you drop vinegar on the rock, does it fizz?
Ooh, and let's go back to our main view. I did. So when I say fizz, I don't mean like fizz, like erupt in bubbles, like dropping Mentos into soda. But if you drop a little bit of vinegar on a rock, and especially if you kind of scratch the rock first, if you see little bubbles coming up, that means the rock is made out of calcium carbonate. Calcium carbonate is one of the minerals in that rock. Most likely, it's limestone or marble. But sometimes you have sedimentary rocks that are cemented together with calcium carbonate. So rock identification can be a mystery. It can be a puzzle to figure out. Is
calcium carbonate like baking soda?
It's very similar to baking soda,
okay.
Yes. Now, this rock here, it does not fizz. So we're going to go to our next branch in our little trail.
All right. So you said the answer was no, so we're following it along this way. Does the rock have layers?
Does the rock have layers? And this one can be a little bit tricky to answer. When I look at this rock, I do not see layers. So, but you know what? If I look at it sideways, I do see some layers. Do you see that stripe of black?
Yeah.
And then there's a stripe of brown. So at first, if I look at the top, I'm going to say no layers. But then if I look sideways, I say, wait a second, there are some layers. So let's say yes.
All right.
It does have layers.
All right. So
we are right here.
Wait.
There.
Oh, does there? Oh, I'm sorry. Did I jump down too far?
Yep.
All right. So yes. All right. We're headed over to here. Does the rock have crystals? I'm sorry.
Or large particles.
Large particles. So are there crystals on that rock?
This is another question that can be kind of tricky to answer. Let's go up to our big view just real quick and talk about why would we care about crystals? And it's because if the rock has crystals that are visible, that really helps us to identify if it's a sedimentary rock or a metamorphic rock. Because crystals form when you have a rock cooling down very slowly, or with a metamorphic rock, sometimes if the rock gets hot enough,
pressure,
you can get crystals forming.
But sedimentary rocks?
Sedimentary rocks, you're going to see grains. You're not going to see crystals.
Okay.
So for this step, you actually need a pretty good magnifying glass or a little pocket telescope to look and see, are there crystals? And on this particular rock here, I could see just some really, really fine crystals.
Aha.
So the answer is yes.
All right. So does it have crystals? So the answer was yes.
And it turns out this is a piece of gneiss, spelled Gneiss. It's a gneiss rock.
I like it.
Gneiss is a metamorphic rock, and that's kind of where it gets its crystals from. And this is actually granite gneiss. It was a piece of granite that was then pushed deeper underground and reheated again and kind of moved. So
nice.
A nice rock.
That's pretty cool. So I mean, this flow chart isn't comprehensive. It's not going to be perfect, but it's going to give us
It will give you
guide.
some good ideas. It will give you some good ideas.
And so when you get a rock, you can just follow that flow chart from answer one question to the next, and hopefully you'll be able to identify what rock you have.
I want to talk a little bit more about mineral hardness because I have here a piece of chalk, and we had a couple good questions in the chat where people were actually asking, is chalk a mineral? And it is. This green sidewalk chalk that I have right here, I would not call a naturally occurring mineral because it was obviously produced and made, by people. But there are natural chalk deposits where this is the mineral talc. That's what this is.
Oh. Talc is that the softest
of all the minerals? That is the softest of all the minerals. So if I take this piece of chalk and I scratch it along my piece of gneiss, what's going to happen?
The gneiss is going to not get dirty, but this will actually rub off.
This will rub off.
The chalk.
It's right. So I just made a streak of chalk across my gneiss rock. What if I do the reverse? I have my piece of chalk here. What if I scratch the gneiss? What if I scratch this rock on the chalk?
Well, once the same thing roughly will happen.
Well, it's gonna make a scratch.
Oh, that
see?
Chalk
so did I get pieces of my rock that rubbed off onto the chalk? No, I made a scratch. But if I take this, I make a streak. That means that pieces of this rock, because it's softer, have actually rubbed off onto my rock. And this is exactly how the mineral hardness scale works. There was a scientist way back when who made the Mohs mineral hardness scale. And he took lots of different minerals and he said, you know what? We can really tell a lot about these minerals just based on how hard or soft they are. So quartz on the Mohs hardness scale has a hardness of 7. Talc, the softest, has a hardness of 1. And our and a streak plate is super useful in telling where you are on that scale. If you take a piece of porcelain, you can even take the bottom of a porcelain bowl. If you have a porcelain bowl at home, use that as a streak plate. If the rock leaves a streak, then it is less than 7 in hardness. If it scratches your porcelain, then it's higher than 7.
Well, that's pretty cool. That's a really good guide right there.
So let's take a look at the whole Mohs hardness scale. You have diamond is at the very top. That is the hardest mineral of all. And we think diamonds are valuable because we have a tradition of putting them in jewelry. But really, the most valuable use for a diamond is cutting things. In industry, with machine shops and all sorts of production lines, diamond drills are used to cut things because they are the hardest thing we have to cut with, pretty much.
Well, that makes a lot of sense.
Yeah. And your fingernail actually has a hardness of about 2, which means that your fingernail is hard enough to scratch certain types of rock.
Like the talc.
Like the talc and like gypsum. So I have a piece of gypsum here, and this piece of gypsum actually came from near Lake Mead, which is right next to where I live. It is a mineral. It has a clear crystal structure, and its crystal structure is so ordered, you can actually see through it.
Whoa.
Isn't that amazing?
So it's so ordered so they're lined up in such a way that light can pass through?
Yes, the atoms are lined up so nicely that light can just pass right through. And this plate right here, if I just take my fingernails aren't too long, but they're long enough. If I push down, I can scratch.
Don't do it.
I can scratch the surface of this because it is so soft. And don't worry, Matt, Dad, we can polish that off later if we want to.
All right. You said this one was called what?
This is gypsum.
Oh, that's gypsum. Oh, that's interesting because when I think of gypsum, I usually think of like sheetrock. So most people have walls that with sheetrock behind the paint, and that sheetrock is made of gypsum.
And it's made of material just like this. So gypsum occurs naturally out in nature. It is deposited, and we go and we harvest it and mine it, and then grind it up and use it to make sheetrock.
So that's probably the strongest thing that our nails can scratch on that Mohs hardness scale.
Yes. All the other rocks, if you try and scratch them with your fingernails, you'll end up filing your fingernails instead. You'll leave a little streak of fingernail on the rock because the rock is stronger. So a streak plate is super useful in telling how hard a mineral is, and then of course looking to see, are there crystals? Now let's go look back. I want to talk about 4 minerals, and then we'll have our where in the world question, and we'll go to our questions for you guys. So if we can go back to the notes real fast.
Okay.
Oh, do you want to say?
Yeah, I just wanted to take another look at this because I think this is so cool. So yeah, we got talc, gypsum, calcite, fluorite, apatite, orthoclase. I've never heard of that. Quartz, topaz, corundum.
Corundum, that's the emerald and ruby.
Yeah. And
Or
then diamond.
sapphire and ruby. Sorry, I said that wrong.
Oh, yes. Yeah, it makes me wonder where emeralds or other gemstones fall in here. Things like pearls. But yeah, so steel nails fall in here somewhere. Glass plate, somewhere between a 5 and a 6. A copper penny, somewhere between a 3 and a 4.
So a copper penny is actually somewhat soft compared to the other items on this list.
Yeah, I usually think of coins as really strong, but
all depends on the coin.
Huh.
All right, let's pull up the notes. We're gonna just come down here real quick on this page 81, because sometimes we think of rocks as just being in neat categories, like that all rocks are either sedimentary, metamorphic, or igneous, but some rocks kind of fall in between. So coal is a sedimentary rock made by ancient plant material that got squashed down to a layer.
Right.
But if that coal is heated enough that it really becomes compact, you could argue that it's a little bit in between sedimentary and metamorphic. Not every rock fits into each category. And this rock that I have right here, this is a small rock, but Matt, I want you to hold it real fast.
Well, that's kind of heavy.
It's really heavy. And then let's look at this close view so I can show this one off.
Is that iron?
This is an iron nickel meteorite, a small piece of a meteorite. And it has so much iron in it, it feels way heavier than any natural rock. And a meteorite, is that a sedimentary, metamorphic, or igneous rock?
Oh,
well,
man.
it all depends. You could actually make an argument that it's any one of those depending on where it came from and what type of meteorite it was.
Wait, what about moon rocks?
Moon rocks are all going to be igneous, pretty much. We don't have the sedimentary, you don't have sediment on the moon that is cycling in layers and compacting. You don't have water moving through to cement sedimentary rocks together, and you don't have plate tectonics to heat up metamorphic rocks. So all the rocks on the moon are igneous, they've been cooled down for a long, long time.
Cool.
Let's look at 4 minerals real fast, and then we are going to get back to our Where in the World mystery and our questions.
All right, so this hard mineral is found in igneous rocks like granite. It's a main ingredient of sand, and when purple, it's called amethyst. That's just going to be straight down to quartz, right?
That is quartz. And Adeline asks, why is quartz so common? It is one of the most common minerals, and it's because it is so resistant to erosion. It just stays around because it's so hard. It's a 7 on the hardness scale, which actually means it's 100 times harder than talc. Is right.
All right. These minerals are the most common on Earth's surface. They come in 3 main varieties: potassium, sodium, and calcium, used in making ceramics and glass.
And I have a hint right here.
Oh,
These 2 varieties that I showed earlier. This is feldspar. Yes. Feldspar is actually the most common mineral on Earth. There are so many different varieties of feldspar. And like you saw from looking at these 2, the labradorite feldspar and the other one, it can look really different depending on what it is.
That's really interesting. I'm curious. Let me know in the chat. Have you even heard of feldspar before? That's not a very commonly used term as far as I know. But, all right. Up next, this mineral will dissolve if placed in vinegar. Okay. So that was calcite.
That is calcite. And then last but not least, we have the mineral that I scratched and that your sheetrock is made out of.
So
gypsum.
soft you can scratch it with your fingernail. That's right. Gypsum.
And last little one I want to show you, this is mica, and it has such dramatic layers that flake off so easily. There was a mica mine in Nevada that was located several hours drive from here, and in the early 1930s at this mica mine, people made windows out of mica. They would take a large piece of mica and they would carefully peel off one of these pieces, and if they got it small enough, it was translucent. Light would pass through, and that's what the miners used to make windows in their homes.
Whoa.
Kind of crazy, right?
Yeah, it is.
So there are so many different cool types of minerals, from mica, which comes in sheets, to selenite, which has this beautiful rose-like pattern, to pyrite, also known as fool's gold, and on and on. I hope this just gives you kind of a fun taste for how much variety there is with rocks, and that you enjoy exploring and learning more about them. And one last little example, calcite has so much variety. This is a piece of banded calcite that our friend who's a geologist lent to me. Isn't that beautiful?
Oh, yeah. It's gorgeous.
But not, this is kind of a rare specimen. Most calcite looks completely different from this. And the little drawing that I showed, we saw that sometimes it can be kind of cube shaped.
Oops.
Sometimes it can form beautiful little structures. Calcite has a lot of variety. All right.
Ooh, one question for you, Science Mom, before we even get to the poll questions. There was one type of mineral that gets used in baby powder, or at least was at one point.
Talc.
That's right.
I do. Talc.
Talcum powder.
Yep. All right. You ready for the Where in the World mystery, Math Dad?
Oh yeah, I'm ready.
This one's a tough one. I don't think you're going to get it.
Okay.
Imagine sweeping white sand dunes, but this isn't a desert. These dunes transform into blue lagoons during seasonal monsoons. Do you have any ideas?
Blue lagoons and seasonal monsoons. Okay, so it's somewhere with sweeping dunes, so somewhere extra sandy, but it's not a desert? How could it be sandy and not a desert? It'd have to be a beach. And you're talking about blue lagoons, so that makes sense. Is it right behind me?
It is not right behind you. So this is a national park in Brazil called, and it's a little difficult to pronounce. I wrote myself a tip, Lençóis Maranhão National Park.
Okay, I have never heard of that. It is beautiful.
And the reason why it looks so amazing is because there are sand dunes, and then underneath that layer of sand, you have igneous rock that is not permeable. That means the water can't go through it. And so when it rains, the rain goes and kind of hits those sand dunes and then just stays there. And it takes a while before it either soaks into the sand or evaporates or slowly runs to the ocean. And it doesn't get very much rain. Just once a year, they'll get these monsoon rains that dump a lot of water, and then the rest of the year it's dry. A really cool environment, and caused in large part by the geology. Okay. By the sand, and then underneath a layer of rock that is not permeable.
Yeah, I don't know. Right? I don't even remember seeing pictures of that before, but that was really neat.
Yeah.
You throw it one more time?
Yes. I'll grab it one more time. There it is. Lençóis Maranhão National Park. It is in Brazil, up near the sort of the top of Brazil.
Huh. Nice.
And now we're ready for poll questions. Go to itempool.com/sciencemom/live, or if you're watching the replay at science.mom, you can click right below the thumbnail and it will bring up the poll questions.
All right. Do we have some birthday shout outs today?
We do have some birthday shout outs. A very happy birthday to Katya, who turns 12 today. Happy birthday, Katya. And a happy birthday to Emraya tomorrow. Woohoo! And Lila from Colorado turns 10 today. Happy birthday, Lila.
Or Lila. I'm not quite sure how to say your name, but happy birthday. All right.
Was I looking at the wrong camera, Math Dad?
No, right here.
Whoops.
We're here. So, as a birthday present, I'm going to crush you guys.
That's what Math Dad thinks, but I don't think so.
All right, first question. What is the hardest mineral in Mohs hardness scale? And I totally spelled Mo wrong, didn't I?
M-O-H.
Uh-oh, M-O-H-S.
That's okay, Math Dad. The unbeatable science kids are very forgiving because they win every time.
All right, and I didn't mean I would crush you on this question. I know you're going to get this one right, most of you, but what is the hardest mineral? And
when we say it's the hardest, the most mineral scale, it doesn't go like a 2 is twice, is a little bit harder than a 1, and a 3 is a little bit harder than a 2. Each time it just about doubles.
Oh, wow.
So the hardest mineral is actually 1,500 times as hard as the softest.
Well, that's pretty cool. All right, and the answer is diamond. All right,
Nicely
didn't
done.
stump many people on that one. All right, got to build you up before I crush you. Question 2, which of these is not a mineral? So select all that apply. So we've got emerald, garnet, opal, sapphire, obsidian, salt. Select any of those that are not minerals. And don't select the ones that are minerals, as we were taught earlier.
I just saw in my notes from the moderators, we also have a birthday to Natalia. Happy birthday today.
Hey, Natalia.
And Creative Koala. Whoop, whoop.
Great. Lots of birthdays. All right, I'm seeing 3 categories get a lot of votes. One's in the lead. I'm not sure.
Interesting. So we have
maybe, are they all minerals? Are
emeralds, garnets, opal, sapphire, obsidian. Most sand that we see is made out of quartz, but I actually have here a sample of sand that is made out of garnets.
Oh,
So,
all right. I'm doing this. Oh, you want me to show that?
yeah, real fast. So this sand, oops, I put it too far. This sand is from near Washington and Oregon. A geologist friend of mine collected it, and all of that, each of that is garnet. And garnet is a precious gem, but these pieces are so small you couldn't cut them into a gemstone.
No.
Isn't that neat, though?
No, that is neat.
And it looks kind of purple.
All right, and so the answers were obsidian and opal.
Ooh.
So there were several that picked other things. So emeralds are minerals, garnets are minerals, sapphires are minerals, and salt is a mineral.
I am so happy to see that salt didn't get as many votes because you guys were listening. Salt is a mineral.
That's right. Okay, so I didn't stump them that time, although I did get several people to pick incorrect answers. Question 3. Which mineral will dissolve if placed in vinegar? We got calcite, mica, quartz, feldspar.
One of these will definitely dissolve, and the others will not.
Ooh. Oh, man.
Isaac had a great question about our rock salt. Why is it pink? And I believe it is, but I would have to double check this to be 100% sure. I believe it's because there are trace amounts of iron in the lake. And I think that's what gives it its pink color. And some halite is pink and some halite is not. You'll find this in different colors depending on where it's formed.
Cool. All right. The answer is calcite. Well done. Well done. Okay. Which 2 gemstones are made of the same mineral? So in particular, of the options listed below, 2 of them are made from the same mineral. I want you to select those 2 and don't select any others.
Only pick 2. Another great question from Pickle Obsessed. Can you make rocks at home with salt? You can definitely make salt crystals at home just by making a salt solution and then putting a string or something that the mineral can form in and letting the water evaporate, and salt crystals will form, and they will have the similar cubic structure as they form. Getting them to grow as big as this, though, is challenging. The biggest salt crystal I've ever grown at home was about that big, and I was so proud of myself.
We'll put it on your tombstone, Sam. So, once grew a salt crystal
that big. It was about the size of a large pea.
All right. And chat says
Woohoo!
Ruby and sapphire. I think that's so cool that rubies and sapphires are made from the same mineral.
They are. They're both
corundum.
Corundum. And corundum is next down from diamond. Corundum is very hard on that mineral hardness scale.
These precious gemstones are typically going to be pretty high on that scale.
Yeah.
All right. Question 5. A rock with layers is most likely to be sedimentary, metamorphic, or igneous. Which will it be?
Isabel had a really great question. Can any rock be a gemstone? Like, how does a rock become a gemstone? And this reminds me of the question, what's the difference between a weed and a flower? And it really all depends on, like, well, what do you want in your garden? If you have a garden and you're growing carrots and then you have geraniums get into where you want carrots to be growing, the geraniums would be a weed. But if you have a flower garden and carrots started growing in your flower garden, you'd pull the carrots. The carrots would be a weed. So with gemstone, it's very subjective. It depends on just minerals that look pretty, that we value. And then you saw that there were some things that are not minerals that can be called gems, like pearl and amber. So I'd say that most things that are gemstones, they are shiny. They can be cut into facets. And that's like that classic diamond shape where that reflects the light. Those are the qualities that most gemstones have.
Yeah, I like that question. Oh man, this was really close for a minute, but then we have one take the lead.
Oh man, Math Dad, are you so excited?
I stumped them.
Just barely.
So the sedimentary rocks, you're going to be able to see these layers in better.
Usually, but this question comes with a bit of an asterisk because it all depends. So usually a rock with layers will be sedimentary, but metamorphic rocks can often have layers too. And that's what we saw with our piece of gneiss. There were some layers in this, and this is a metamorphic rock.
Okay, so that one wasn't so cut and dry.
Well, we'll still let you have your victory, Math Dad.
Take that. All right, and we have a bonus question here.
Oh, I love this question. I'm really curious. I purposely didn't talk about this too much because I wanted to see what you guys thought.
Is a glacier a rock?
Is a glacier a rock? And remember, a rock has to be naturally occurring, it has to be formed from minerals, and it has to be solid. So is a glacier a rock? What do you think?
Oh, man. Ooh.
It's almost tied. It's almost tied.
Glaciers were not on your chart.
They were not. Ooh, Remington Wolf asked a good question. How hard are teeth on the Mohs scale? They're harder than fingernails, but I'm not exactly sure how hard. I wouldn't want to test it.
That's a really good question. I think your teeth are stronger than bone. The tooth enamel, that's my understanding.
I would have to look it up, but that would be a fun one to look up.
Yeah, really good question. You guys are deep thinkers. I like this. All right, I think it's time to call it and reveal the answer. Yes, a glacier is a rock. I can't believe they got that right.
So let's go back to this view really fast. I think that deserves, because that last question was kind of a harder one. I think that deserves a victory dance, Math Dad. What do you think? Do you want to show them the victory dance you made for yourself? So Math Dad.
One of these days I'm actually going to win, and then I'll show my victory dance.
Here's the Math Dad victory dance. that was the one that he said he was going to play in Celebration, and so technically, yeah, we'll give you a victory, Math Dad. All right, is a glacier a rock? This is a question that if you ask a room full of geologists, you will actually entertain some lively debate. But most geologists will take that traditional definition of a rock that we just gave you, that it's naturally occurring, and it is made from minerals, and it is solid. And so, what type of rock is a glacier?
Well, what mineral are we referring to here? Water?
Yes. So it's made of the mineral ice, and it's a sedimentary rock because you have snow that comes and layers together and compacts the glacier. So most people will agree that a glacier is a rock, which means that we live on a world with an ocean of lava.
Whoa.
Because water is like the melted form of glacier, technically.
That's kind of funny.
Yep. One more question I want to answer real quick before we close. Kelly asked, why would a cut and polished gemstone be so much more money than just a plain gemstone? So for example, this piece of citrine here, when it's cut and polished into a faceted gemstone, it's much more valuable. Part of that is because it takes work to cut and polish a gemstone. And if you do it wrong, then you've got to throw that piece of rock away and get another one. And it takes a lot of work and skill to be able to cut it.
I think a lot of the value of gemstones is just, it's been inflated by the jewelers who want to sell them. And like the diamonds are actually way more common than you would expect based off of the fact that diamond rings cost so much, but the prices have been artificially inflated.
Somewhat artificially inflated, yes. And two really great questions that I'm going to research, and I'll have answers for you on Friday. What's the oldest mineral in the solar system? Love that question, Rosalita. And then what's the rarest rock that someone could get? I would have to do some research for that. I will see what I can figure out.
So on Friday, we'll be doing some art projects, and we'll even get to do some math.
We do. We're going to talk a little bit about ellipses and orbits on Friday. Work hard, grow smart, and we will see you soon.
Bye.